Let us find the Fourier series of a square wave. So this is a square wave. So it's a square wave, and look at the amplitude. This is plus a and this is minus a. It's a square wave. And what of the full square wave? That ends with t. The half will be t by 2. Starts with 0. So 0, t by 2, half, and this will be your full. Okay, your t, 0 to t. So your full wave becomes 0 to t. The amplitude plus a for during this interval. The amplitude minus a for during this interval. See, you have plus a and minus a, and this is for up and this is for down. So you have plus a for when t lies between 0 and t by 2. See, 0 and t by 2, and t by 2 t by 2 t minus a. This is your minus a, this is your plus a, and p of t is given us for a square wave. So we have written so far f of t, f of x. So in some other book you can find p of t, so we can write p of t. So p of t equals plus a during this interval minus a during this interval. Your a0 is given as 2 by t, 0 to t. This is a square wave. We are talking about change of interval. See, this is change of interval because interval goes from 0 to t. So earlier for Fourier series, pi 0 to 2 pi or minus pi to plus pi. That is for Fourier series. Now change of interval, change of length interval. Now it becomes t here. So we will calculate now a0. a0 equal to 2 by t, 0 to t, p of t dt. Your p of t in this interval, a 0 to t by 2, and p of t in this interval is minus a. So this becomes minus a. In this interval, t by 2 to t. So here it becomes a, and this will be minus a. So you have t by 2. I have written the same thing here. Here it is a, and this is minus a. Now I can pull a out. So 2a by t. I can integrate. So that will give me t 0 to t by 2, and here t by 2 to t. So substitute the upper limit first. That will give me t by 2. Substitute the lower limit will give 0. Now minus is here. Substitute the upper limit, that will give me t. Substitute the lower limit with a minus sign already is there. So minus minus plus, so that will be plus t by 2. This t by 2 is 2t by 2. 2 will get cancelled. We have t. And this minus t is there. That t and this t will get cancelled. So a0 will be 0. 0 multiplied by 2a by t, that will give me 0. So your a, there is no coefficient. First Fourier coefficient, there is no Fourier. First Fourier. So a0 equal to 0. Now we will go for an. An is given by 2 by t, 0 to t by t, a cos n omega t minus t by 2 t, a cos n omega dt. N omega t dt. Now you pull a out and integrate. So on integration cos n omega t, that will give me sin n omega t by n omega. On integration of cos n omega t, that will give me the same. But limits, what are the limits? First we have to substitute the upper limit. So substituting the upper limit, that will give me sin n instead of n omega t. We will have to substitute, instead of t, we will have to substitute t, capital T. So that becomes n omega t by t. Is it okay? See here, instead of t, we will have to substitute capital T by 2. So that becomes n omega capital D by 2. But we know omega equal to 2 pi by t. Omega t equal to 2 pi. So instead of omega capital T, we will have to substitute 2 pi. That 2 and denominator 2 will get cancelled. We have 2 pi. I repeat, n omega t. Instead of t, we will have to substitute capital T by 2. So omega t by 2. Omega t is nothing but 2 pi. So 2 pi by 2, that will give me, that 2, t by 2 will get cancelled. We have n 2 pi. Okay, this n omega is pulled out. So we have sin n 2 pi by 2 t by 2. Okay, this 2 will get cancelled. See, this 2 and this 2. Instead of t, I have substituted capital T by t. See, capital T by t. You have omega t is nothing but 2 pi. Okay. Now substituting the lower limit will give me 0. Now substituting the upper limit will give me this. Substituting the lower limit will give me minus t by 2. See here, minus t by 2. Now we have this 2 and these 2 will get cancelled. So we have 2 sin n omega. Okay, 2 sin n omega. And this t will get cancelled. Correct? Sin 2 pi is 0. Sin 0 is 0. Sin pi is 0. Sin 2 pi also 0. So this term will become 0. What is the last term? Last term will be t will get cancelled. Okay, your 2 also will get cancelled. You have sin n pi. Okay, sin n pi. So we have now sin n pi, and you have sin n pi, and this sin n pi will give me 2 sin n pi. So I repeat, see here, sin n 2 pi by t, these 2 and these 2 will get cancelled. This t and this t will get cancelled. We have sin n pi, one sin n pi exists. Go for the last term. Last term is 2 will get cancelled. T will get cancelled. We have sin n pi. This sin n pi and this sin n pi will give me 2 sin n pi. That's all. And now we'll come here first. Okay, these 2 and these 2 will get cancelled. We have sin 2 n pi. That's all. You leave it. Okay. Now 2 sin n pi minus sin 2 n pi. When you are going to substitute whatever may be the values of n, that will become 0. So your an equal to 0. Now we'll go for bn. Similar expression, bn is equal to 2 by t, 0 to t, a sin n omega t dt. So you have to separate the limits, 0 to t by 2, t by 2 to t, we have separated. Okay, I have pulled a out, so 2a by t. So on integration that will give me minus cos n omega t by n omega. On integration that will give me this. For minus is that minus and this minus will become plus. So this minus exists. This minus exists. Here there is a minus sign. This minus and this minus will become plus. Now substitute as usual. Substitute the upper limit first. So you have minus cos n 2 pi by t multiplied by, instead of t you have to substitute t by 2. Substituting the lower element will give me cos 0. You have to substitute the lower element. Now next one is cos n 2 pi by t multiplied by, first substitute upper limit. Substitute the lower limit will give me minus cos n 2 pi by t multiplied by t by t. Okay, cos 0 is 1. So I have written 1 here. Cos 0 is 1. The last one, 2 will get cancelled, t will get cancelled. You have cos n pi. You have cos n pi. What is the first term? You have cos n 2 pi. This t and this t will get cancelled. 2 will get cancelled. Again you have cos n pi. So cos n pi minus cos n pi will give you minus 2 cos n pi. Okay. Now this becomes 1. This t and this t will get cancelled. Okay. You have cos 2 pi. Cos 0 is 1. Cos 2 pi also 1. So 1. 1 is here. So we have 1 plus 1, 2 here. 2 minus cos n pi. And here I have pulled all the denominator out. So t n omega. Instead of omega t, instead of omega can substitute 2 pi by t. This t and this t will get cancelled. We have 2 pi n. So 2 pi n. This 2 and this 2 will get cancelled. We have this 2 you can pull it out. So that will give me 2a by n pi. Remaining term will be 1 minus cos n pi. Cos n pi can be expanded as minus 1 to the power n. So bn is given by this. So bn is given as 2a by n pi. I have written the same thing here. For n equals 1. For n equals 1. Suppose if n is 1. If n is 1, b1 is given as 2a divided by pi. N is 1. 1 minus 1, that will give me minus of minus plus. Or we have 2. So 2 2s are 4. 4a by pi. For n equal to 2, substitute n equal to 2 here. So this becomes plus. Minus 1 to the power 2 is nothing but plus 1. So 1 plus 1 minus 1, it is equal to 0. For all the odd numbers there exists minus 1. For all the even numbers this will become 0. Okay. See here, n4 equal to 0. n4 if you substitute 4 here, minus 1 to the power 4 is nothing but plus 1. So you have 1 minus 1 0. n equal to 3 there exists minus 1. So you have 4a by 3 pi. So your bn equal to 4a by n pi for all odd n. So your f of t is given as already your a naught equal to 0, an naught 0, your a naught also 0. So an is 0. Your bn is given by this expression. So your f of t will be, your bn is given by this expression. So f of t equal to sigma over for all odd numbers there exists a series 4a divided by n pi sin n omega t. So we will stop here. Okay. So our Fourier series is given by this expression. Okay, expanding. Your Fourier series is given by this expression. Your A0 equal to 0, A0 is 0, your Bn alone exists. You substitute Bn here, see Bn already substituted. So 4a by pi sin omega t we can expand. Now, what about the ratio of amplitudes for the series? The ratio of the amplitude for the series. See here, series. For a square wave. For a square wave, the amplitude is given as. So these are the amplitudes. These are the amplitudes. 4a by pi is an amplitude. Here 4a by 3 pi is there. So 1 is to 3 is to 5, 1 by 5 is to 1 by 7. See here. This is your amplitudes. These are the amplitudes. These are the frequencies. See omega, 1 omega, 3 omega. It is the frequency. 5 omega. So 7 omega. So there are the ratio of frequencies given as 1 is to 3 is to 5 is to 7 is to 9 is to 12 goes on. Here it is 1 by 3. See here it is 1. 1 by 3, 1 by 5, 1 by 7, 1 by 9. It goes on. Okay. So f of t is given as. So f of t is given as. We can pull 4a by pi out. So that will give us this. The series shows the square wave. The series shows the square wave. If we take the first 3 terms, then the curve is shown as a continuous one. So first we are going to take the first 3 terms. 1, 2, 3. Okay, it's a continuous in the first figure. So this is continuous. Suppose we are going to take the number of terms, infinite terms. See, look at the infinite terms. That will give the exact square wave. See, this is a square wave. So you have to take infinite series. That's why this Fourier series are infinite series. You have to take the Fourier series as infinite, large number of terms. We are going to include large number of terms. This will become a square wave. First 3 terms here, first 3 terms we can't judge whether it is a square wave or not. See, this is not a square wave. So we'll stop today. We will see in the next class. So bye students.